In our exercise number 3, we have a function for which we have to find the derivative at a point that I call P in the direction of the vector that I call A that's given to us. So our formula will be in the end something like this. Let me write it first of all. Now it looks very complicated, but if we break it down in pieces, let me write this better actually. It becomes pretty simple. So the first part is going to be this one right here. So the derivative, uh, the gradient of our function, that's going to be the derivative of our function in terms of x in the, let's call it I direction. Let's use it the x direction, plus the derivative of our function in terms of y in the j direction, plus the derivative of our function in terms of z in the k direction. So that means that we have derivative of x y squared plus yz over dx in our case, and then the first I. I'm just gonna write for the first one, not gonna write every single time. So if we take the derivative of this, we get y squared, direction of I, plus the second term will be then 2xy plus z in the j direction, plus y in the k direction. Let me put a hat for every single one of them. That's easier to notice. Alright, now that we have this, we have to find this gradient at point P. That's what this means. This line at the point, the letter P, is at point P. So everything we need to do is simply rewrite this equation that we just got. So y squared, direction of I, plus 2xy plus z in the j direction, plus yk in the k direction, in the k direction, and we need to plug in the point P. In this case, our point P is 1, 1, 2. So instead of the x, we're going to write 1. Instead of the y, we're going to write 1. And instead of the z, we're going to write 2. So our first one will be 1 squared, which is 1 in the I direction, plus 2 times, we have a 1 times 1 plus 2 in the j direction, plus 1 in the k direction. So here we get I direction, plus we're going to have 2 times 1 times 2 times 1 times 1 equals 2 plus 2, which is 4j hat plus k hat. And there's our gradient at that point. Now what we're going to have to do is, oh, sorry, here I made a mistake. It's not going to be the vector, it's going to be the unit vector A. So we're going to find the unit vector A. Let's do it right here. So for next, what we have, so we're going to have our vector A over the magnitude of A, which is then going to be equals to 2I minus j plus 2k times 1 over 2 squared plus 1 squared plus 2 squared, which is equals to 9, so 1/3, times 2I minus j plus 2k. So let me copy this one. We're going to have to add the last step to our thing. So we had the gradient of our function at point P we found times the vector A. So we're going to have our vector A that is equals to this, and everything else we found so far is this function right here. Get closer, so it looks better. So here we're going to have then a 1/3, and then the I times the I, so the value of the I times the value of the I, so it's equals to 2, plus the value of the Y times the value of the Y, which is equals to actually negative 4 plus 2, which is equals to then 0, so our answer is actually 0. Let me make sure this is correct. So it's the problem number 3. Uh, yes, our solution isn't incorrect. Our final answer will be 0. Remember that our answer actually has to be a value. It's not a vector, it's going to be a simple, oops, let's call it this. It's going to be a number, it's not going to be any vector. It's going to be a number because we're talking about how much does that increase in that direction at that point. So we don't need any of the vector because we're not going in any direction. We don't need any function because we said how that varies in the graph and then at a single point. So we have to get perfect value. This means, for example, that if we had a something like this, which represents, for example, how high we go with this part being the top, the highest of the mountain, this being the medium, and this being the lowest. It means that, for example, we found a point here in this direction. So as you can see, the height remains the same, and that's why it's equal to 0.